Hey, welcome to the Midwest Renewable Energy Fair. Here in part 2, we're going to talk about things that are important to all sorts of alternative energy products, and that's storage. And these big red boxes are batteries. Look at how big they are. And it looks like they're made in the USA by Rolls, a leading manufacturer of batteries for the alternative energy industry, typically used for photovoltaics. Here's another battery company, Trojan, with storage battery systems. Look, there's those lugs we talked about in part 1. And this is what's inside these batteries. This is a lead grid that's used to hold lead oxide. That's where you get all your power from. They stack them in those batteries, and the more there are, the more the battery costs and the more storage you get. And here's a PV system that doesn't need to use batteries. Let's listen in and see how it works.
This is an electrical cabinet that we added here. It includes, houses 2 inverters, something like the inverters that you see here. Inside of that cabinet, there's 2 10-kilowatt inverters, and what those inverters are doing is converting the DC energy from the solar electric modules into AC energy. Comes through an electrical panel, a disconnect, and a meter, and go right back to the utility at their transformer. And in that way, this meter shows up on the customer's bill along with their regular usage meter in the building, which is back this way. And so their bill ends up being the net result of the two. So they cover a pretty good chunk of their energy, depending on the time of the year, between 50 and 75% of their energy consumption.
And how many kilowatts is this?
This is about an 18 kilowatt system as far as all of the modules, and on the AC side with the inverters is 20 kilowatts.
Cool.
So it rises and sets.
Okay, keep talking.
And
tell me again about the fact that you can get, so you're taking in sunlight from the back and the front?
Right, these modules are a particular type that's called a double-sided or bifacial module, and not only does it accept light from the front like a standard module, but it also accepts light from the back. The back side of the cells are exposed. It's glass on the back as well, like they are on the front, so it can take in any reflected light, like from a snow-covered area, or white cars parked underneath, or when the sun actually very early in the day or very late in the day in the summertime is actually coming up in the northeast and setting way in the northwest. So that gives it some additional output depending on what's around it. Every application would be unique, but between 5 and 30% more energy just because of that kind of a feature.
Cool. Okay, let's jump to another storage issue. We touched on this in part 1, storing heat as biomass, or storing heat within the stove, making its slow delivery and efficiency improvement. Heat release comes from a unique design using silicon carbide. Great for those eco homes commonly found in this area. Let's listen and hear more. This little chip right here is revealing what this is made out of.
It is, yeah.
It is silicon carbide, which is some kind of a cementous material.
It's a mineral.
It's a mineral.
So it's a heat-fused mineral.
Here, what we see as the ultimate time delay biomass converter is this wood gasification boiler from Effecta. This Swedish solution provides the cleanest, most efficient burning of even green biomass. Let's hear what he has to say. Wood gasification boiler, what is that all about?
Wood gasification boiler, we have the top chamber. We put in approximately 100 pounds of 20% moisture content wood or so. And we heat up the wood just enough to convert wood to gas.
Okay.
We take the gas with a negative draft motor, we pull in the gas, it comes down through a ceramic with a stainless steel burner in which we inject air. So now you have a gas-air mixture, and when the gas and the air collide, you get a 40% increase in BTU, so that your temperature down here is not creosote, but is dust, because we reach 2,000 degrees Fahrenheit in our secondary chamber. So it's a primary chamber, secondary chamber.
Cool.
And then we have a lambda sensor that controls our dampers based on the CO2%.
Watch, you can see those little dampers open and close to provide air.
that will control those dampers throughout the entire burn to maintain optimum gas.
Okay, here's the storage part. These tanks would normally be insulated.
Because we burn at 2,000 degrees Fahrenheit and we do not shut our fan off, we run the boiler for 5 hours, produce approximately 600,000 BTUs of energy, and throw it in a storage tank.
In water form?
In water form. To be used when we need it. You can also put a hot water solar collector in the same tank to supplement. So now you have a complete package.
And that 600,000 BTUs would be enough to keep a good eco house warm for a week or two in the winter. Efficiency thing there, the turbulator, the tubes.
Yep.
About 2.5 feet?
2.5, 3 feet.
Yeah.
Interesting. And it's all so you can remove it like this so you can clean
Clean
it.
it. Every 250 hours, I take a brush that they.
Okay, here's another heat exchanger in a water tank that is to provide storage of solar heat. And here we see the construction details. That's porcelainized steel tubing within a porcelainized steel tank, insulated by isocyanurate insulation. Here we see a gas-fired water storage tank in which we can see the turbulators and improve burn efficiencies in the Effecta's wood burner. This tank is a part of the solar domestic hot water heating system from Velux. This cool-looking insulating foam housing covers the pump and stuff. Velux reduces solar phobic realtor reaction by hiding solar roof panels, disguising them as skylights, which are perceived by these people as more important to resale value. It's a great concept that is working well to reduce summer water heating costs in areas where conservative realtors shun ugly solar collector installations. As you can see, these Velux windows are beautiful. No ugly phobia here, but let's go to the car show and see what's kind of green and kind of ugly here. And it's a Daffy, a 1960 DIF 600 electric. What a color. What an ugly. Boy, it's a Daffy. I guess it's a work in progress. And its beauty's obviously under the skin, where we see more batteries. This electric car is chock full of storage batteries and uses lots of connector lugs and exemplifies our story here today of green and storage and connections. Remember those connections? Our last little story about storage will leave your mind racing. These tanks hold natural gas. Yeah, natural. CH3 pure methane. It's the cleanest carbon fuel, and you get it from the utility. It's normally used to cook with and heat your home in the city. Special car and driver are running on it, racing to tell you about how you'll save the earth and a lot of your own green money by using methane instead of gasoline. It all starts with the special cars, sometimes right from the manufacturer or modified. It's a tried and true conversion that's been working for many years and has proven great success. What you need is this unit from cngpump.com, connected to your gas line in your home that fills the car with cooking gas, much like you'd recharge your batteries in a plug-in hybrid with electricity. And speaking of plug-in hybrids, we're going to end with the MREF plug-in Prius stored under a solar collecting panel / carport that charges its battery from the sun. Hey, we're just about out of time here. Be sure to go to our website, getgreentv.com. Share this movie with others at YouTube and Facebook. And thank you for watching today.